Hi, there are a few things I want to go through when we're looking at compare-contrast examples of an incomplete answer, a minimal answer, and a complete answer. So for each unit, we're going to have available your topics, and then you'll have your compare-contrast prompt. So for Unit 1A, my sample prompt, which is not the one you'll see on the actual semester assessment, is compare and contrast a line and array. And we're going to look at the next slide to see some answer examples. So here's an example of an incomplete answer. Compare and contrast a line and array. A line goes in two directions, and array only goes in one. Okay, so they did contrast, but they didn't compare at all. This would be worth 10 out of 20 points. Okay, Unit 1A, same question, compare and contrast a line and array. Both are one-dimensional and infinite in length. The line goes on forever in two directions, whereas the array has an initial point and a directional point. So this is a minimal answer. It's worth 15 out of 20 points. My complete answer has the same as the first one, and then it also talks about the naming conventions used for lines and arrays and how they're different, and how for a line you can use your two letters with the line symbol over and the order does not matter. But for the array, the order is important. You have to start with the initial point followed by the directional point and use your little array symbol over the letters. Okay, so incomplete, minimal, complete. Unit 1, this is actually 1B, this needs to be fixed. Points, lines, and planes, topics covered. We have angles, adjacent angles, bisected angles, complementary, supplementary, linear pairs, and verticals. So I know my compare-contrast is going to be something about these. Okay, the sample one that I have is compare and contrast adjacent angles and bisected angles. Again, this is not the same compare-contrast you will see on the semester assessment. Here are my incomplete, my minimal, and my complete answer examples. So for my incomplete answer, they're next to each other, bisected angles are equal. Okay, so I do have a small compare, I do have a small contrast, but it's not complete, and so it's only worth 10 out of 20 points. Here, both angles are next to each other. Adjacent angles do not have to have the same measure, but bisected angles do, so again, a minimal answer worth 15 out of 20. And here is my complete answer. Both angles are next to each other, share a vertex and array, do not overlap. So that's what they have in common. Here's my contrast. Adjacent angles do not have the same measure, can be added to find the measure of the whole angle. In contrast, a bisected angle creates two adjacent angles, so there are adjacent angles in my bisected angles that each have the same measure. My adjacent angles do not have to have the same measure. Okay, so that's my complete answer worth the whole 20 points. The next unit is logic and lines, my types of reasoning, counterexamples, conditional statements, equations, slopes, distance, transversals, and parallel lines. So that's what we're going to see. Our compare-contrast topic will be somewhere in here. The sample one, which again will be different from the one you'll see on your assessment, is compare and contrast converse and inverse statements. We're going to look at the next slides for answer examples. Okay, so again, I have my one is switch and the other is negate. Okay, so again, that's incomplete because I didn't compare them at all. I just said what was different about them, and well, which one is switch and what does that mean? Which one is negate, what does that mean? Okay, my minimal answer does have my compare. They're both if-then conditional statements. The converse is switched and the inverse is negated. Okay, and then my complete answer with 20 of 20. Both are if-then conditional statements transformed from an original conditional statement with a hypothesis and conclusion. So it tells me where they came from. And then in the converse, what is switched, right? This one doesn't tell me what I'm switching. It just says switched. Here it tells me what I'm switching and what I'm switching in the inverse, or what I'm negating in the inverse. And then it even goes on to tell me that they can both be true or false statements. Although I would consider this complete with these first two little short paragraphs. I wouldn't necessarily take off points if you left that part off for this type of an answer. Okay, so hopefully that helps you see what the differences between incomplete, minimal, and complete answers are. Unit 3 was my congruent triangles, but it had a lot of other things. It also had some theorems, classifying triangles, and isosceles triangles, so your compare-contrast could follow any of these. The sample that we have is to compare the angle-angle side and angle-side-angle congruence postulates. So we're going to look at the next slide to see some answer examples. So here I have some wordy things. I have which answer do you think is the incomplete, the minimal, and the complete answer. A lot of us get into the mindset of thinking if I type a whole lot, that's definitely going to give me all the points. And so some of us write really long dissertations and hope to get all 20 of our points. The more we write, the more points we're going to get. But let's see if this is the complete answer. And then one of these two, these are about the same. Which one of these would be minimal and which one of these would be incomplete. Okay, so let's look. The next one's going to be my incomplete answer. And notice this is my longest one. This one is a long paragraph that says pretty much nothing. Listen to it out loud. When we compare the AAS and the ASA congruence postulates to see what they have in common and what properties they have that are different, we can see they both use angles and sides in their usage to be used in geometry. Stop and think about that sentence right there. They use angles in their usage to be used. We learn to use them. So this is just not really saying a whole lot. It's just using words, right? We learned to use them when we were learning the other postulates, and then they would just listed the other postulates, which aren't important to what we're trying to do here. And then which ones we can't use, which again doesn't help us compare and contrast the ones we're talking about. So that was what they put for the compare part. In the contrast, when we contrast the AAS and the ASA congruence postulates to see what they have that's different, we look at the order of the letters, and we can plainly see that the letters are in a different order. The first one has the S last, no second, as in the angle side angle congruence postulate. So we can see the postulates are different because the letters are in a different order. So again, this is a lot of words, but this doesn't really tell me anything about AAS and ASA. Okay, so again, more words doesn't equal better answer. Okay, on the next one, this is my minimal. Okay, when I compare and contrast the AAS and the ASA congruence postulates, we can see they are both congruence postulates used to prove that one triangle is congruent to another. Okay, in contrast, the location of the side is different depending on the triangles and which postulate you should choose to use. The letters are in a different order. Okay, so this does say that they're both congruence postulates, but it doesn't mention that they both require two angles and one side. Right? That's what they really have in common. They both require two angles and one side to prove congruent. My difference is that the location of the side is what's different. So that's why this is a minimal answer. It's a correct answer. It's just not complete. Okay? The location is different, but what is different about the location, right? That's what I need still here. I need what is different about the location, and here I need, other than proving congruent, they both need two angles and one side. Okay? Look at my complete answer. Angle, angle, side, and angle, side, angle are both acronyms for postulates used to prove triangles congruent using two angles and a side. Okay, so I mentioned what those A's stand for, why there's two of them, and why there's one S on both of them. Angle, angle, side is two angles and a side not included between the two angles, whereas when using angle, side, angle, the congruent side must be included between or connect the two congruent angles. So it tells me what is the significance about the location of the S, not just that the S is in a different location. Okay? So again, when we look, the size of the answer does not make the better answer, right? This one was a lot of words to say not a lot much, right? Whereas this one was probably the fewest words, and that was my complete answer. Okay, let's look at the next one. Topics covered. We have composite area. We have all of those centers and parts of triangles, our triangle sum inequalities, our hinge theorem, and our exterior angles inequalities. Okay. And the compare contrast that I have put here is not the same one you'll see on the assessment, but it's compare contrast altitudes and perpendicular bisectors of triangles. So now all of these are pretty wordy, but let's look and see if we can figure out which is going to be which. So let's go, and if you want, you can pause and kind of read through and think about which one you think would be which, and then we'll look and see what the minimal one is next. Okay, my minimal one is, they're my incomplete one, sorry, we should go incomplete first, The altitudes and perpendicular bisectors of triangles have things in common, and they have properties that are different. Okay, that's good because we're comparing and contrasting. Altitudes can be found in triangles as well in perpendicular bisectors. Those are also in triangles. So again, not really telling me anything about them. Both altitudes and triangles are in triangles, and there are 3 of each that intersect in one point. Okay, that's true. There are 3 of each. So we finally got something that we can compare. Okay, the differences between altitudes and perpendicular bisectors is the way in which they are drawn. They are different types of lines that are drawn in triangles. So while they are similar, they are also different and each have their own unique properties about them. What are those properties? For example, their intersections have different names and their locations in the triangle are different. So we still haven't written down any properties about them. We haven't given the names of those intersections or where their locations are, right? And then the last little part here we put, when we look at an altitude and a perpendicular bisector, we can see they are different and we can tell them apart by the properties they have and how they are drawn in a picture. So this is another example of somebody who wrote a lot of words but didn't say anything, right? So again, we are reading these for content, okay? So the goal isn't to write as much as you can write. The goal is to write good content, okay? And if that takes 1 sentence or 2 sentences, then that's all it takes. If it takes a couple paragraphs, then it takes a couple paragraphs, right? But the more words you write does not necessarily mean the better answer, okay? When I look at this one, this is minimal. Altitudes and perpendicular bisectors of triangles are similar yet different. They are both lines that intersect sides at a perpendicular or 90-degree angle. What makes them different is another point they intersect. The altitudes, like the perpendicular bisector, must intersect the opposite side at a 90-degree angle and has to leave a vertex. The intersection of the altitudes is also different from the intersection of the perpendicular bisector. The intersection of the altitudes is also called the orthocenter. Okay? The perpendicular bisector is different because it doesn't have to go through a vertex. It can go through a vertex, but doesn't have to. The intersection of the perpendicular bisector is also a different intersection with a different name from the altitudes intersections. The intersection of the perpendicular bisector is called the circumcenter. Okay, so this one does have a lot of accurate information in it. It is really wordy for what they said. There's a lot of words in here, or a lot of sentences in here that could probably have been left out and not have changed the gist of the paragraphs. But there is no mention of the perpendicular bisector having to go through a midpoint, of it having to bisect a side, right? And there's no location of the location that makes the altitudes or the perpendicular bisectors different, or the intersections, the locations of those either. Okay, so let's look at that's the minimal. Let's look at a complete answer. Okay, altitudes and perpendicular bisectors are both perpendicular to a side of the triangle. The altitude must also pass through a vertex and can be inside, outside, or a side of the triangle. The perpendicular bisectors do not have to pass through a vertex. Instead, they must intersect. Here I have my midpoint. Okay. The point of intersections for an altitude is called the orthocenter and can be inside acute triangles, outside obtuse triangles, or at the right angle, right triangles. The point of intersection for the perpendicular bisectors is called the circumcenter and is the center of the circle drawn around the triangle, equidistant from each vertex. It can be inside acute triangles, outside obtuse triangles, or at the midpoint of the hypotenuse, right triangles. Okay, so this is a complete answer, not nearly as wordy as the first one, kind of close to the second one, but a complete, full answer. Okay, so again, incomplete, complete, minimal. My complete is actually the shortest of all 3. So again, the more words doesn't mean the better answer. Okay, so hopefully this helps you with some examples. If you have any more questions on looking at these, I'm trying to get to the front, there we go, compare, contrast examples, please make sure you ask during sync time or at tutoring. Okay, thank you so much for watching.